Question 15 is about comparing experimental and theoretical probabilities. Here we have a situation where a student spun a spinner with four equal sections 100 times. Now imagine a spinner is like this, four equal sections, red, blue, green, and yellow. It's given over here. It's 100 times spun. Okay, and there's a pointer which will denote which is the color, and recorded the results. The results are over here. Find the theoretical probability of spinning blue. Now, in theory, if you have four equal sections, how much probability that you will get blue? It is always probability is given by desired outcome by total possibilities. Total desired by total possibilities. Okay, so here then, what is the desired outcome? 1, right? And total possibilities is 4. 1 by 4 is 0.25. That is the thing, or it's 25%. If you multiply this by 100, you'll get 25%. So that is the theoretical. So in theory, because there are 4 equal sections, you have to get 25% chance of 25% possibility of blue. Now, what's the theoretical probability of getting a head in a coin? It's 50 because there are only two possibilities. 1 by 2, it's 0.5 or 50%. Same way over here, there are 4, so it's 1 by 4. Nearest tenth they have told, so it will be 0.2. In percentage they have mentioned, so it's 25%. That's it. There's no decimal after that. So that will be the answer. You can see here, it is 25%. But now, what is the experimental probability of blue? When they did the experiment, they got 38 out of how many tries? 100. That is 38% basically. That's the answer. By the way, theoretical probability can be written like this as well. Total was 100. In 100, you can get 25, so it's 25%. But it's simple as 1/4 quarter is the answer as well. So in theory we get 25%, but practically when they did it, they got 38%. That is the answer over here. Now, the second one, a student flipped a coin 125 times and recorded the results. You can see over here heads and tails. First, we have to do the theoretical probability. I'll write TP and then the experimental probability EP. So, theoretical probability, it is just 1 by 2 or 50%. Okay. Whereas this is a electronic part, so you can just choose the correct answer. Theoretical probability 50%, experimental probability here, what do they want is landing on heads. Heads is 73 by total times is 125. You just have to put this in the calculator and you'll get the answer. So let's put in 73 divided by 125. The answer is 0.584. That's 58.4% experimental. See, theoretical 50, but over here we get 58.4. That's the answer. Now then we have a six-sided die. Now what is the theoretical probability? Directly you can tell it's 1 by 6, or you'll just get 16.67%. Since it's nearest 10, 16.7. Okay. But what about this? It's 150 times totally in experiment, and they want to know how many times you get 3. So it is 27 over here. You can use the calculator and solve it. It'll be 9 by 50. So that would be the answer. Let's put in the calculator and check. Here we have to put 27 by 150. The answer is 18% basically. So it's very, very close to the real one. Say theoretically you should get 16.7%, and in experiment they're getting 18%. That sounds fair. And now we hear Tiana sells handmade earrings online. Last month she sold 60% of her inventory. Design and run a simulation that she can use to estimate the probability of selling the inventory. See, now over here, you're more likely to get the previous questions for your exam, because over here you need to write your own experiment. See, we are not going to do the experiment when you're in the exam, but what they're expecting is, I'll just show you over here. This is the probability of last month. In the next month, you need to get values near to this. So you're just modeling a experiment. So you can take 60%, right? A circle, a spinner, where 60% over here, 60% would mean something like that. Imagine that's out of 360 degrees, multiply this by 60%, you will get some answer, right? So many degrees, it'll be about 200 something degrees, okay? So that degrees means she's selling. Over here, other degrees it's not selling. And then you basically spin it and see how many times it'll fall on selling and non-selling. And then you see the experimental probability. Now over here they're telling, see here, they have done this is sample answer. It's not accurate. It's just a sample answer. You don't need to do all this. It's just telling that you've done an experiment and telling the sold outcomes, right? With 32 times, whereas not sold was 82 times out of total 50 times. So here the theoretical probability is supposed to be 60 in the last month, right? But when you did the experiment and did the simulation, you got 0.64, that is 64%. Yes, that is accurate. You can say that it's accurate. Okay, it doesn't make much sense because they're not, they have to give you that, then only you can find the experimental probability. So focus more on the first three questions. Here, I think so you might be given this table and you have to just find the experimental probability. That's it. And here, programming. Lama designed a soccer computer game. He coded the program such that the player will make a goal on 35% of the attempts. 35% chance, yes, it'll attempt. Paula is testing the game and thinks there may be an error in the game's programming. She attempted to make 30 goals and only 4 were successful. Run and evaluate the simulation and decide whether Paula is correct. Now, I still remember my students when I was doing this problem in the class, they were telling, no, this is absolutely right. Maybe there's Paula's skill issue, you need to have skill when you're playing. So that's something they were telling. But over here, we can't take skill and everything as a consideration. We have to just look into the probabilities. So let's see here. Paula made 30 attempts. 30 attempts, that's total 30. How many were successful? 4. Let's find how much is this probability. Here we will have 4 by 30. That gives us 13%, 13.3%. But originally it had to be 35%. It's way too low, isn't it? So we can consider that there is some error over here, because this one over here, actually it is 35%. But when we do when we see this one over here, okay, they are expecting you to do an experiment. If you should just tell you did an experiment like, spinning a spinner or something, and then you got around 41%. So if you do a spinner, say a spinner with 35% goal and remaining 65% not goal, this is not 35, but it's not accurate, not a goal. And then if you do an experiment over here, they got 41% in the experiment. So what you can say is, if you do the experiment, it's coming closer to the original value. So whatever Paula got, it's 13%, way too low than the actual value. So you can say there is some error in the programming. So that's how we solve this question 15. In the exam, don't worry, they are supposed to give you the experimental probability table, and then from the table you can easily find experimental probabilities.